Hi, my name is Milan, and in this video I'm going to talk about the option monad, or the maybe monad as it's often called, and you're going to see how the option monad will help us to get rid of nulls in our C# code. We have a lot of code to go through, so let's jump into the example. I have two versions of this code in my solution. Inside of these two projects, I have the nullable project and the option monad project. The example here contains a research project class. I'm going to show you what it looks like in a moment. A research project can contain an experimental phase with any number of experiments inside, and an experiment can have a result. We also have the research analyzer that can generate a research report for a given project, and we're going to print that out to the console. I'm going to leave the nullable project as is, and I have the same exact copy of this code in the option monad project that we are going to refactor. And what I want to highlight here is how null proliferates through our entire code base when we start using it. Let me give you an example. So let's say I want to access my research project. I can take a look at the existing properties, and you will see that it has an experimental phase that can be null. If I try to access some property of the experimental phase object, we're going to be warned by the compiler that this could be null, which you can see here with the squiggly underline. So how you can avoid this is by adding a safe access operator, which is the question sign. I think it's also called the conditional access operator, and it's only going to access the right-hand side value if the left-hand side is not null. So let's see what we have on the latest experiment. Let's say I want to access the result property. Again, the latest experiment instance could be null. So I have to use the safe access operator, and then I can access the result, and let's say I just want to get the confidence score. So in this case, I can't make it a decimal because this could still be null, and even if I add a safe access operator to the result, it's still going to return null, and I will have to handle this with the null coalescing operator. What this is going to do is give me back the left-hand side of this operator if it's not null, otherwise give me back the right-hand side. So you can see how convoluted our code becomes, and it's not very clear what is going on here, or at least it's not explicit enough. Now let me give you another example. Let's say I want to sum the scores for the experiments that I have in this experimental phase. So what I can do is say project experimental phase, and then I can access the historical experiments. Let's actually make this a bit more readable. And let's say I want to filter out any experiments that still don't have a result. So I can say where the result is not null. And in that case, I'm going to sum these results. And let's say I want to sum the confidence score as in the example above. So you will see that even in this case, I'll have to handle the possibility of a null happening. So I'm using the null coalescing operator. But what you can also notice is that even though we have a where statement here with an explicit check that the result is not null, the compiler isn't really able to pick up on this, and we're still getting a warning that the result could be null. Now you can get around this with the null forgiving operator, but this creates more problems than it solves, and if you try to use the safe access operator, then it changes what we are calculating. You will see that without it, the sum is calculating over a decimal, and if I apply it, then it's using a nullable decimal type. So quite quickly, nulls become scattered through our entire code base. So let's go into the research project type, and let's explore how the option monad can help us get rid of nulls in our code. And before I show you how we could implement an option type in our code, I have to mention that right now, C# does not natively support this. There's a language proposal for introducing type unions into C#, which are essentially discriminated unions, and I won't spend my time going through the entire proposal, but I want to highlight part of it that's interesting to our example here. So let me just find it. And I finally stumbled upon it. And you can see that some common union types, which are given as an example, are the option type, which is just a wrapper around some value, which is a generic argument here. And this value could either be there, so we have a some option, or the value could not be present, or it could be null, and we have a none option. You can also see some possible usage examples. This isn't too relevant for our use case because we don't have access to typed unions in C#. Another monad that's commonly used in functional programming, and it's something that I've covered on this channel in the past, is the result monad, or the result pattern as I like to call it. You can see that it has a similar structure with a success and a failure object, And this would be an example use case. I don't want to spend too much time on this. I just wanted to mention that this is something that we will probably get in C# at some point. Now let's go back to our example and see how we can do this today. So what is a monad? A monad is a special value that encapsulates some sort of type inside. So let's create a class called option with a generic argument. And let's even say that this generic argument has to be a reference type. So the option monad will represent a wrapper or container around some generic type represented by T. So the first thing that we will need is a way to store this type inside of the option monad. So let's create a private read-only field called value, and it could be null. Let's also create a private constructor. So I will say option that accepts a nullable value. And let's just assign this value to the private one that we have. And I will even use an expression bodied constructor. But this constructor is private. So let's go back to what we actually need for this to be a monad. And that is a function to create an instance of this monad. So if you recall from the typed unions example, we could have a sum value where we accept a T that is explicitly not null. And all we have to do is just create a new instance of our option type and pass in the value. And then we have another constructor or function to create the option monad called none, and it's just going to return a new instance with a null value inside. We could also use default because the default value for a reference type is null. So this is about 1/2 of what a monad needs. It's going to be a structure that wraps some value inside. It exposes a set of methods or functions to create an instance of the monad. And what we are missing is a set of functions or methods that allows us to compose operations on this value. So we are going to explore this in just a moment. But let's first see how we are going to use our option type. So we're going to replace our nullable reference types with an option type. So this is going to be an option of an experimental phase. You will see how this requires us to make a few additional changes. Now I need to update my constructor argument to make it explicit that this accepts an option of an experimental phase, which means it could be a non-value, or in other words, it doesn't exist. Let's also do this for all of the nested types inside. So an experimental phase has a nullable latest experiment. So I'll have to replace this with an option of an experiment. And let's also update the property value so that it's the same type. So I will update this property here. Then if I go into the experiment, you will see that the result is nullable. So let's also make it an option of a result. So let's update that. And if I go into the result, there are no nulls here, just 2 decimal properties, so it won't require any changes. So now I can close this down and we can go back to our research project where we defined our option. And if I try to build the project right now, it's going to fail because I have some compile warnings. So if I go back to my program file, you will see that how I'm creating the research project is no longer working. I have to make it explicit that this is an option. So I will say option result sum, and now I can pass in my result instance. One thing I did miss here is to make these functions static so that I can actually use them in a static context. So now this should work. So let's also do this for the second result. I have to say option result of sum, and now I'm making it explicit that this value could be null. And if I did want to make it null, I can do that by saying option result of none. So our code now better communicates when something is there and when it's not. This is also going to be option of experiment of sum, and we'll pass in the experiment value. And then this is going to be option of experimental phase of sum, and we'll pass in the experimental phase instance. So this should be compiling now, but when we go into the research analyzer, we're going to run into a few problems. For the time being, let me just move my option type into the root of this project, for example. Let's move it there, and let's go into the research analyzer. And you will see that we have a lot of compile errors here. So let's see how we are going to fix them. So let's examine the get research stages method. And you can see that most of the issues here are because we are doing some null checks. So if you recall from earlier, the experimental phase could have been null. The latest experiment as well could have been null. So this code accounts for both of these cases. Now we made it explicit that these values are null or that these values could be null. So what we did with the option monad is we made it explicit that these values could be missing. And what we can do now is use this to our advantage to compose some functions on the option monad. So let me show you how we are going to do this. I'm going to introduce another method here that's going to allow me to map from one instance of an option to another. So let's call it map. It needs a generic argument and is going to accept a function that uses our generic argument t and returns a value that's of type t out. So let's call this the map function. I need to add a respective generic constraint, and then let's say if the value inside of this option monad, the value that we are containing, is not null, then we can safely call our mapping function and pass in the value. Otherwise, we're going to return an option of t out, and we can say none to return an empty option for this type. Now, because there isn't an explicit conversion between t out and option of t out, I have to say option of t out and then sum, and then pass in the value returned by this function. And what this allows us to do is to say return, and then I can take in my project and access the experimental phase, which is an option, and I want to map this into a list of strings. So I can access the phase and return a list of strings, and let's instantiate it to contain the phase name. So I'm going to say phase and then phase name, and this will work because none of these values are null. So these two lines of code help us get rid of what we have here, but we also have to take care of the latest experiment and appending the name of the latest experiment to our list of strings. So we need to introduce another function into our option monad, and this one is going to be slightly different. What's interesting about the map function is that it cannot fail, whereas the function that I'm going to introduce now could fail, and you will see what is the difference here. This function is called bind, and it also accepts a function argument. The first parameter is t, and the result of this function is an option of t out. So you can see how it's slightly different than just returning the t out value. And let's call this bind. I need a generic constraint that t out is a reference type, and then the implementation is very similar. I will say if the value is not null, then we're going to bind our value, and this returns an option back. Otherwise, I'm going to say option of t out, and then we can say none. And then in order to save us some time, I'm going to write out another function called match. It's also a generic one, and here I'm going to accept another function that uses the value of this options instance and returns some value t out, and we will call this sum. And I'm also going to introduce another function that returns this value, but I will call it none. And in this case, we can just say if the value is not null, then we're going to call sum and pass in the value instance. Otherwise, we will call none. And this will allow us to invoke some code if this value is not null, and we have a sum option type, and when the value is null and we have a none option instance. Now forgive me if I'm using the words function and method interchangeably. I tend to consider them the same thing, even though in an object-oriented programming language this is called a method. So now let's go back to our example and let me show you how we can solve this. So this is now a list of strings that represents our experiment stages, and what I can do is access my research project, use my experimental phase, and now I want to bind this to return an option instance back that's a different type than the experimental phase. So what I want to do is to safely access the latest experiment value, which could be null, and then I want to call match on my latest experiment instance, and this will allow me to define a function that's going to be called when this is not null. And in this case, I want to access the latest experiment, and let's convert this into an option of list of string, because this will be the new return type of our method. And now I'm going to say sum, and we can use C#12 collection expressions to concatenate these values, and I'm going to append the experiment name. Let's also handle the none case, and in this case we are just going to return option of list of string, and I will say sum, and we're just going to pass in the list of stages. Now I need to update the return type of this method to make it explicit that this is an option, and now we got rid of the null, and we can remove all of this code, and we are left with this functional block of code that allows us to compose on the option monad. So hopefully this illustrates the high-level examples of how the option monad works, how we can compose on the option monad using the map and bind methods, and how we can match on the option monad's value using the match function, and how we can unwrap on the option monad's value using the match function. Now, in order to save us some time, I'm going to speed up the implementation of the remaining methods, and we're just going to discuss the most important differences. So the analyze experiment trend method takes in a research project, and it's first going to ensure that the experimental phase is not null and that we actually have some historical experiments. It's going to return null if that's not the case. Otherwise, it's going to filter out for the valid results, and if there aren't any, it's going to also return null until finally it's able to calculate the experiment trend. And here we are calculating the average confidence and the trend direction for our experiments. Now you will notice that there are some null forgiving operators here so that we can actually safely access these values, and these are all remnants of having to use nullable reference types. I'm going to leave this in place, and I'm going to add the functional implementation of this code, and we will have to update this method to return an option. And then let me add the missing method. So I have a filter method here, and here's what the implementation will look like. We're going to accept a predicate that filters on our type and returns a boolean, and if the predicate returns true, then we will return some of this value, otherwise we're going to return none. So if I go back to my research analyzer, I also have a property here checking if this option instance is a sum instance. If we had type unions in C#, this would look much cleaner, but for now I will have to make do with a property, and the value of this property is going to check that the wrapped value is not null. So if I go back to the research analyzer, this is now succeeding, and I will also have to solve this method called value or throw, and you can probably figure out what it's doing. It's going to return the wrapped value if it is not null, otherwise it's going to throw an invalid operation exception. I'm also using the null coalescing operator that's going to throw the exception only if the left-hand side is null. And with these changes in place, my method is now compiling. So let's examine what this version looks like. We can now safely access the experimental phase because it's an option instance. And I can filter on this option instance by checking if there are any historical experiments. If I manage to get past this filter, I will have a sum option instance, and then I can bind on this instance and extract the valid results and finally calculate my experiment trend. And you will notice that nulls have completely disappeared from our code, and everything is either explicitly there because it's not null, or we have to check that the value is present because it's an option instance. Let me update the remaining methods. Here I have to find the most successful experiment. So I will first update this to return an option of an experiment, and then I'm going to update the implementation to work with the option monad. I'm going to do the same in this method that's generating a research report. So let's start by wrapping this with an option instead of returning a nullable reference type. And now I can update the implementation into this version. And there are some problems that we will still have to solve. We will get back to that in just a moment. And I just want to update the last method here to make it use my option monad. So let's update this from nullable reference types into the option type. And now I'm going to update the code into a switch expression. And you can see how the code becomes much more concise, and it's pretty explicit when the value is there and when it's not. I can do a pattern match on the isSum property. When we get typed unions in C#, this is going to look even better. And with these changes in place, let's go back to the previous method where we have some compiler warnings. So what is the problem here? If I go into the research report type, you will see that it's relying on nullable reference type for the latest confidence score and the most successful experiment. So what I could do is replace all of these values with option types. So let's do that. I can do that here. I'm going to update the trend and the stages, and then everything should be fine. I can get rid of this. The most successful experiment should also work as expected. So you can see that this works, but if I try to update the latest confidence score to be an option, I will run into a compiler error. And this is because of how I defined my option type. So you can see that the warning here says that the type decimal must be a reference type in order to use it with the option. And this is actually our generic constraint here. So how are we going to solve this? Well, what I can do is to create another option type There's going to be a struct, and it's going to allow me to work with value types. So I'm going to call this the value option. It's going to be generic, and my generic constraint will say that this has to be a struct. Let's also wrap some value inside, and I'm going to copy some of my implementation that I already have to speed up the process. So this is what I'm going to reuse from the option implementation. I'm going to explicitly pass in null here because a default value for something like an integer or decimal could be 0, and I want to explicitly make this null. I'm going to add two more methods to this implementation. I need a match method that's going to be invoked if the value that I'm wrapping here has a value, it's not null. Then I can call my function to return something. And I'm also going to define a function that's going to give me back the value if it's not null, or it's going to invoke some function to return some default value. So let's move the value option into its own file. And I'm going to add another method into my option type to allow me to map from an option instance into a value option instance. So now I can go back into the research report, update this to a value option, and if I go back to the research analyzer, it's going to compile, and now my code is working as expected. So now if we take a look at our program file, you will see that we are running into a bunch of compile errors, and mostly because we are checking if the report is null or not, and this is never going to be true because our option can never be null. So we can get rid of this, and how we would approach this with a nullable type is exactly like this. Run an if statement and check if something is null, and if it's not, do this, otherwise do that. With an option type, we compose on the option monad or the option instance using the match function. So I'll go back to my option, and I'm going to add one more overload of the match function that doesn't return a value, it returns void, and it allows me to run some actions if this is a sum option or a none option. And I'm also going to add a value or method that allows me to provide a default value if the wrapped value is null. So now let's go and rewrite our program file to make use of the option monad. So now I can say report and match, and if this is a sum instance, then I'm going to execute what I have here. So let's copy this. Otherwise, if it's a non-instance, then I'm just going to execute an action without an argument, and this is going to be this code here. So I can now delete all this, and this is what I'm left with. Let me update this to reference my inner variable, which is the actual report, and then we will get another set of problems. For example, the stages is an option of a list of strings. So I can say value or, and this is going to give me the list of stages if it's not null, or it's going to invoke a function that's going to give me back my default value, and I can just pass in an empty list. For the latest confidence score, we want to convert this into a string if it's not null, or return the not available string if it is null. So how I can do this is say match, and if the value is there, I can say return value to string. Otherwise, you're going to return not available. I can do the same for the experiment trend. So let's go ahead and say match, and I'm going to say use this value and give me back the trend direction as a string. Otherwise, you're just going to return not available. And then for the most successful experiment, I can just say give me the value or this default value here that's going to say not available. And this is what the updated version of the code looks like. We're using the match method on our option instance and running a piece of code if the value is not null, or another piece of code if the value is null. And this is how you can introduce the option monad into your code. Now, if you don't want to implement this from scratch, there's an awesome NuGet library that you can explore called language extensions. This is the library I'm talking about, and you can go ahead and install it, and it comes with a bunch of functional features that you can use. Among other things, there is a result monad and an option monad inside. So this is something to explore if you don't want to implement this yourself. Now let's actually comment on the benefit of using an option monad and a result monad that I covered in some of my past videos. The main idea here is making it explicit that something could either be there or not be there. We also want to give our caller the option to be able to compose on this value and do something if the value is there, it's a sum option, or simply skip the operation if this is a none option. And this way of writing code is considered pretty normal in most functional languages. Among other, there is F#, but also Java has an optional type. Also Rust comes with built-in result and option monads. So this is something that's very common except in C#, at least until we get typed unions, which is when I expect the functional way of writing code using monads to become much more mainstream with C# developers. For now, we have to make do with something like this, which isn't ideal, but it can help us write some pretty expressive and explicit code. It definitely takes some getting used to writing your code like this, and I found that you need to have your team on board for this to make sense, because if some developers are using option monads and other developers are not, then your code base is going to look like a big mess. I also wanted to comment on the difference between the option monad and the result monad or the result pattern. The option monad is there to tell you that an object, let's say a list containing a string, is either there or not there. The result monad is there to tell you that an operation can either succeed or fail. So it's a higher level concept than the option monad. If you enjoyed this video, make sure to click the like button. Also, let me know in the comments what you think about functional programming and if I should keep making videos about functional programming with C#. If you want to learn how to use the result monad to get rid of exceptions in your code, then you should watch this video next. Click the subscribe button under this video so that you don't miss my future videos. Check out my clean architecture and modular monolith courses to improve your skills, and until next time, stay awesome.